Think you know space? What if I told you there's a planet made of diamonds out there, a cosmic jewel gleaming against the black velvet of space? And that's just the beginning. We're about to embark on a journey to the edge of the universe and back, a quest for knowledge that will reveal the most astonishing, mind-blowing truths about the cosmos. From stars that collapse into objects denser than anything imaginable, to a storm raging for centuries on a planet so large it dwarfs our own, prepare to have your perceptions of reality challenged. Did you know that space itself is expanding faster than the speed of light, or that somewhere out there it might rain molten metal? Buckle up, because these 10 mind-blowing space facts will change the way you see the universe. Our first stop takes us to our nearest planetary neighbor, a world shrouded in thick, swirling clouds of sulfuric acid. This isn't some alien hellscape from science fiction, but Venus, a planet so similar in size and mass to Earth that it's often called our sister planet. But don't let those superficial similarities fool you. Venus is a world of extremes, a cautionary tale of a runaway greenhouse effect. And here's the first of our mind-bending facts. A day on Venus is longer than its year. Imagine that for a moment. On Venus, the sun rises in the west and sets in the east, and it does so very, very slowly. In fact, it takes Venus 243 Earth days to rotate just once on its axis. But here's the kicker. It takes Venus only 225 Earth days to complete one orbit around the sun. That means a year on Venus is shorter than a day on Venus. How can this be? Well, it all comes down to Venus's incredibly slow rotation and its orbital dynamics. This strange quirk of cosmic mechanics highlights the incredible diversity of worlds that exist in our universe. Even within our own solar system, we find planets with characteristics that seem utterly alien to our own experiences. So the next time you think about a day or a year, remember Venus, the planet where time itself seems to dance to a different tune. Let's journey now to a realm where reality outshines even the most extravagant fantasies. We're talking about a world so opulent, so extravagant, that it makes the Hope Diamond look like a speck of dust. This, my friends, is 55 Cancri E, a planet twice the size of Earth located some 40 light-years away in the constellation of Cancer. What makes this planet so special? Prepare to have your mind boggled. 55 Cancri E is a planet made largely of pure, crystallized carbon. And what happens when carbon is subjected to immense pressure deep within a planet's interior? It forms diamonds. Yes, you heard that right. 55 Cancri E is a diamond planet, a celestial body of unimaginable wealth. Imagine the riches, the sheer brilliance of this cosmic jewel. If we could somehow transport even a small fraction of this planet's riches back to Earth, it would disrupt global economies overnight. But 55 Cancri E's value goes far beyond its potential material wealth. This gleaming world serves as a reminder of the boundless possibilities that exist in the universe. Out there, among the trillions upon trillions of planets, are worlds that defy our wildest imaginations. So, the next time you gaze upon a sparkling diamond, let it carry your thoughts to 55 Cancri E, a testament to the universe's capacity to create objects of both stunning beauty and unimaginable value. We often depict space battles in science fiction movies with roaring engines and exploding spacecraft. But in the real universe, those dramatic sound effects simply wouldn't exist. That's because space, my friends, is a realm of profound silence. Here on Earth, sound travels through the air as vibrations. These vibrations travel through our eardrums and are interpreted by our brains as sound. But in the vacuum of space, there is no air, no medium for sound waves to travel through. It's a perfect vacuum, a silent stage for the cosmic drama to unfold. Imagine, for a moment, being an astronaut on a spacewalk. You're surrounded by the breathtaking beauty of the cosmos, billions of stars twinkling like celestial fireflies. But all you hear is the gentle hum of your spacesuit's life support system. The universe, for all its grandeur, is utterly silent. This absence of sound isn't a void to be feared, but an opportunity to appreciate the universe in a different way. It forces us to rely on our other senses, to see the beauty of a nebula, to feel the awe of a distant galaxy. So, the next time you find yourself surrounded by noise, take a moment to appreciate the silence. Let it remind you of the vast, quiet expanse of space, a place where the universe speaks to us not through sound, but through the silent language of light and gravity. Our journey now takes us to the remnants of dead stars, to objects of unimaginable density, where a teaspoonful of matter could outweigh a mountain. We're talking about neutron stars, the collapsed cores of massive stars that have gone supernova. Imagine a star, more massive than our sun, crammed into a sphere with a radius of only a few miles. That's a neutron star in a nutshell. The gravitational forces are so intense that protons and electrons are squeezed together, forming a sea of neutrons. To grasp the sheer density of a neutron star, consider this. A single sugar cube-sized amount of neutron star material would weigh over 1 billion tons on Earth. That's equivalent to the weight of Mount Everest, condensed into a space smaller than a playing die. The existence of neutron stars pushes the boundaries of our understanding of matter itself. These exotic objects are natural laboratories where the laws of physics are pushed to their limits. They're cosmic lighthouses, emitting beams of radiation that sweep across the cosmos. So the next time you stir sugar into your coffee, let your mind wander to the incredible density of neutron stars, a testament to the universe's ability to create objects of mind-boggling extremes. Now let's delve into one of the most mind-bending concepts in all of physics: time dilation. This isn't science fiction, but a real phenomenon predicted by Einstein's theory of relativity, and it has some rather curious implications for space travelers. Time as we experience it here on Earth isn't constant throughout the universe. It's relative, meaning it can be affected by factors like gravity and speed. The stronger the gravitational field or the faster you travel, the slower time passes for you relative to someone in a weaker gravitational field or at rest. This means that astronauts aboard the International Space Station, for example, actually age slightly slower than people on Earth. The difference is minuscule, only a fraction of a second over their time in space, but it's measurable nonetheless. Think about that for a moment. Time itself isn't absolute, but a fluid concept that bends and warps under the influence of gravity. It's like traveling with a slightly slower clock, one that ticks at a different pace than the clocks on Earth. So, while we haven't quite cracked the secret to eternal youth, time dilation offers a tantalizing glimpse into the malleable nature of time itself. It's a reminder that our everyday experiences of the universe are just a small part of a much grander, stranger reality. Hold on to your hats, folks, because we're about to tackle a concept that's as mind-boggling as it is fundamental to our understanding of the universe: the expansion of space itself. And yes, it's happening faster than the speed of light. Now, before you say, "But Neil, nothing can travel faster than the speed of light," hear me out. Einstein's theory of relativity, which sets the speed of light as the cosmic speed limit, still holds true. But it's not objects themselves that are moving faster than light, but the very fabric of space-time that's stretching, carrying those objects along with it. Imagine baking a loaf of raisin bread. As the bread bakes, the dough expands, carrying the raisins along with it. The raisins themselves aren't moving within the dough, but the space between them is increasing. That's analogous to what's happening in our universe. The implications of this expansion are profound. It means that the distances between galaxies are constantly increasing, and the farther away a galaxy is from us, the faster it appears to be moving away. This expansion also tells us that the universe we observe today is vastly different from the universe of the past, and it will continue to evolve in ways we can only begin to imagine. Let's take a moment to contemplate the sheer scale of the universe, a concept so vast, so mind-boggling, that it defies our ability to truly grasp its immensity. We're talking about a universe filled with more stars than there are grains of sand on all the beaches on Earth. Think about that for a second. Every grain of sand on every beach, every desert, every playground, sandbox on Earth, and then multiply that number by, well, a lot. The observable universe, the part we can see from Earth, is estimated to contain over a septillion stars. That's a 1 followed by 24 zeros. And here's the kicker. The observable universe is just a tiny fraction of the entire universe, which could be infinite in extent. So not only are there more stars than grains of sand on Earth, but there might be more stars than grains of sand in an infinite number of Earths. This vastness can be both humbling and awe-inspiring. It reminds us that we are but a small part of something much grander than ourselves, a cosmic tapestry woven from billions upon billions of stars. So, the next time you feel insignificant, remember those countless stars, those distant suns, and know that you are part of something truly extraordinary. Our cosmic journey now takes us to the largest planet in our solar system, a gas giant so massive that it could contain over 1,300 Earths. But we're not here to marvel at Jupiter's size, but at a storm, a swirling vortex of wind and clouds that has raged for centuries, the Great Red Spot. This isn't your average hurricane. The Great Red Spot is so large that you could fit 2 to 3 Earths inside it, and it's been swirling in Jupiter's atmosphere for at least 400 years, ever since astronomers first observed it with early telescopes. Imagine a storm that has outlived empires, that has raged on while generations have come and gone on Earth. The Great Red Spot is a testament to the power of nature, a swirling reminder that even on a planet without a solid surface, weather can be a force to be reckoned with. Scientists are still trying to unravel the mysteries of the Great Red Spot. What powers this massive storm? Why has it persisted for so long? These are questions that continue to fascinate astronomers. So the next time you look up at Jupiter in the night sky, remember the Great Red Spot, a storm for the ages, a swirling vortex that has borne witness to the passage of time on a cosmic scale. We often visualize the planets in our solar system as being incredibly far apart, separated by vast gulfs of empty space. And while it's true that the solar system is largely empty space, the distances between planets might be smaller than you think. In fact, if you were to take all the planets in our solar system and line them up edge to edge, they could all fit comfortably within the average distance between Earth and the Moon. That's right, the entire planetary family from Mercury to Neptune could squeeze into that seemingly small gap. To put that into perspective, the average distance between Earth and the Moon is about 238,900 miles. That's a lot of miles, to be sure, but it's dwarfed by the vastness of space. And it's amazing to think that all those planets, each a unique and fascinating world in its own right, could fit within that distance. This little thought experiment reminds us that even though space is vast, it's also surprisingly compact in places. And it highlights the incredible scale of our solar system, a place where even the seemingly empty spaces can hold surprises. So the next time you look up at the Moon, imagine all the planets lined up between us and our celestial neighbor. It's a mind-boggling thought, but it's a reminder that the universe is full of wonders, both big and small. Our final cosmic destination takes us to the remnants of stars like our Sun, objects that have reached the end of their lives and collapsed into incredibly dense objects known as white dwarfs. Don't let the dwarf in their name fool you. These stellar remnants are anything but diminutive when it comes to their density. Imagine a sphere roughly the size of Earth, but containing a mass comparable to our Sun. That's the kind of density we're talking about with white dwarfs. In fact, a single teaspoonful of white dwarf matter would weigh as much as an adult elephant here on Earth. It's hard to wrap our minds around such extreme density, but it's a testament to the incredible forces at play within these stellar remnants. The atoms themselves are crushed together, their electrons squeezed into tight configurations, creating an object so dense that a thimbleful of its material could potentially punch through a planet. White dwarfs represent a fascinating stage in the life cycle of stars, a kind of stellar afterlife where these once mighty furnaces of nuclear fusion slowly cool and fade over billions of years. They're cosmic time capsules, holding within their dense cores the secrets of their former lives as brilliant stars. So, the next time you encounter an elephant, let it serve as a reminder of the incredible density of white dwarfs, these tiny but mighty remnants of stars that pack a cosmic punch. As we conclude our brief sojourn through the cosmos, remember that we've only just scratched the surface of the universe's infinite mysteries. Every corner of the cosmos holds new wonders, new challenges to our understanding, and new stories waiting to be told. Never lose your sense of wonder, your thirst for knowledge. Keep exploring, keep questioning, and keep looking up at the night sky with a sense of awe, for it is in the vast expanse of the universe that we truly discover our place in the grand scheme of existence. The cosmos is calling, inviting us to explore its boundless frontiers. And as we venture further into the great unknown, we do so with the knowledge that the most profound discoveries are yet to come.